Welcome back, everyone, to the Cancel for Maintenance podcast. If this is your first time joining us, we are a podcast that takes a behind-the-scenes look into the gritty, non-glamorous life of aviation maintenance. We share some laughs, impart some wisdom, all in hopes of giving you that split seconds relief in your day that can prevent a mishap. I am your co-host, Six.
I am MVP.
And our third co-host, Shoreline, is silently sitting in the back, adjusting knobs, making sure our audio is good to go, and ensuring our faces stay fit for radio. So we rarely cover crashes and mishaps, mostly because when dire situations like these come up, it's typically sounded all around the corners of the land, and the horse gets beaten beyond the point of glue.
Plus, it might be what you say is, too soon type situation, and out of respect for the dead, if you will, or maybe it seems a little tactless to discuss it.
Yeah, that too. And usually most mishaps, there's going to be some type of loss of life involved, and that's as MVP said, like we like to not dance around graves for the most part. I mean, if there's a life lesson to learn, like say they lived, then maybe, but yeah. We do, however, want to take this time today to emphasize the importance of testing, troubleshooting, following proper steps, to remedy shortfalls, maybe mitigate some risks before they escalate into issues, which in some cases you may not have the wiggle room to escape from. At the time of this recording, we just received news that the Titan submersible from Ocean Gate was lost at sea, most likely due to a catastrophic implosion of the vessel's hull. The current root cause or expert weigh-in on the most likely of causes is still ongoing, and probably by the time this episode airs, we may or may not have learned more about what happened. We will say, like, our condolences go out to all the families of the crew and the amount of effort that went into trying to refine them. So with that said, from what we understand now about some of the likely causes of this incident, it seemed like this all could have been preventable or at least better mitigated. So what we know of so far with this sub is it's probably very generous to call that a sub, for one. I mean, I think like the monitor that was used in the freaking Civil War was a probably better suited sub than what this thing was, So
old Ironsides,
Yeah. And we say that based on some articles that came out just within the last 12 hours about this incident. And from what we gathered, some of the stuff here was very hodgepodge together, or it wasn't well thought of. Let's call it.
Let's just say like the R&D was very minimal on this project, right? And why Six and I want to talk about this today is the importance of research and development, the R&D, the importance of testing.
Yes.
All various aspects of it, right? Most of us in aviation, my side, I've worked in test environments quite a bit. You're constantly testing new modifications, softwares, altitudes, temperature, stresses, all sorts of stuff. Well, submarines or submersibles or hollow weights, essentially, should undergo the same thing, because just the amount of stresses and pressures an aircraft experiences at high altitude, go the other way with the added weight of gravity on a submarine.
Yeah. So an example, like for some of us, besides like the R&D of it all, is like, say you're fabricating parts, for instance, like say pressure treated lines or hard solid lines. You would have some individuals that like, just make it look like this and move on with life. And I admit, I've done it before. Like, I just get like a work sample and take it to whoever the hydraulic shop is. I'm like, hey, just make it look like this. It's like, well, I cannot just make it look like this, right? There's all sorts of things that go into it. And that's kind of a callback to one of our previous episodes about owner produced parts. Like, you cannot just look like that. It has to have all kinds of specs to go with it. And I give this example because, like, say with hydraulic lines, for instance, once it's made, you can't just like send it to the line. It has to go through a sort of test to make sure that it's not going to burst before we expect it to. And most hydraulic lines, depending on the size, it usually has a burst pressure limit of anywhere between 6,000 to 8,000 psi, and that's a lot. I mean, and for the most part, like, you're not gonna take it to 8,000 unless you already have a second one, kind of like a destruction sample or a destruction inspection for it, just to make sure, like, hey, these two are exactly identical. We're gonna run one through the test and see when it bursts. So if this one breaks, then we pretty much know that this one's about the same one. So kind of off tangent example of that, but the reason why we want these kind of tests, and we've been in situations before where certain individuals of a higher collar value would try to push through these things to either get it done faster or just skip it altogether because we have a low risk of failure or whatever those cases may be. There are certain things that you just shouldn't skip. An example is like, say, like with hydraulic lines, or in our current example with the submarine, there are certain things that you might not want to just wish-wash your way through it. And MVP brought up a great example before we started the episode where, like, certain designs with this submersible and other similar submersibles weren't exactly up to par or weren't within standard, as we would call it.
Yeah, I mean, when there's a video I think that they did maybe a year and some change ago with the CEO, and they were explaining, you know, the ins and outs of the submersible, you know, and they were showing that here's these monitors, here's the porthole, here's this bathroom, you know, and here's how you control it, a Bluetooth, you know, wireless game controller. And, you know, and while it all looks cool and sci-fi-ish and whatever else, it looked very... Well, it looks like something, you know, you might build for a home gaming station or a backyard build, or I don't know, you know, a Gen 1 rendition that you're going to essentially explode in a pressure tank. Yep. You know, it's not going to survive its first. It's basically made to be destroyed.
Yes.
But you might test out your softwares and stuff in it, and these different applications, and these monitors and XYZ, and okay, you know, here's where we NDI'd it, and here's where we learned our stress cracks are at this level, and then at this level, and at this level, and then at this level is catastrophic failure. But we know we can make it to this level, and the hull will still remain intact, but we can't go any further. We got to resurface, you know. And even then, even the interviewer of that article even said it looked very, what did he say? It looked very homemade, you know, and it wasn't that wasn't a term of endearment the way he said it.
Yeah.
and, you know, the design as well, right? You get in through the nose, and the nose is bolted on from the outside. So once you're inside, there's no escape. No emergency hatch, no anything. So that's also a problem, because let's just say, you know, you get down to 500 meters and you start noticing some portholes and stuff starting to fail. There should be at least an emergency exit. So once you get back to a certain level, that hatch will pop and you can at least get out and swim the rest of the way up, or whatever, I guess. I don't know. I'm not a submarine expert. But what I'm saying is research and development to know the weak points, to then strengthen those weak points, and then determine safety issues from there, resolve those safety issues, and make it a repeatable unit. You think SpaceX, how many trial and errors did they go through developing reusable rockets, and are still going through?
Right. You know? Yeah. I think their one saving grace on that is it's unmanned, right? So they're pretty much just like throwing up a really, really, really expensive lawn dart strapped to a gasoline tank. You know what I mean?
Yeah.
There's more to it than that, obviously, but that's more or less what they're doing. They're strapping a lawn dart to a fuel tank and then sending it up as high as it can go. It's like the most expensive freaking kid project ever. But anyway, but like as MVP was saying, like this whole test, check, verify, retest, check, verify, retest. This cycle exists for a reason because of stuff like this. And going on to what MVP said about safety is apparently there was a interviewer who was shown these subs, was shown this, and he was made aware of a prior or a former employee of this company that made a complaint to all the safety councils and whatnot, or safety associations, that said this thing is unsafe and it's made out of material that's not rated for this type of a dive. It's not safe at this type of a dive, and the max depth that this thing is certified, air quote certified and rated for, is like maybe a third of what the target depth of where we're trying to go. So for everyone keeping track at home, the submarine was trying to take a tour of the Titanic, which is sunk in the North Atlantic Ocean.
12,000 feet down.
Yeah. So 12,000 feet, that's about 4,000 meters, right? For all our non-imperial
all of our metric friends.
Yeah, all our metric friends. So about 4,000 meters, right? The submarine that this former employee said was only rated up to 1,300 meters or 4,600 feet. That's quite a difference, to go for...
That's a massive difference.
Like think about that, right? Like, hey, we have this thing. Let's call it a sub. It's max rated for 4,000 feet. That's burst pressure, 4,000 feet. And you know what? Let's take this to 12,000. Why not? Why not? Sounds like a huge concern, So for that to just say, you know what? Let's just roll it. I'd be really unsafe about that. And then same interviewer from the one who wrote that article, he went down on a dive with a similar sub from that same company just last year. And something about the electronics broke or malfunctioned or something. The submarine basically got lost for a couple hours. Like they lost communication, they lost contact, and the submarine itself, they didn't know where it was at in the depths in the ocean. Like that would be scary as shit. I mean, when you're that far down, there's no phone a friend. There's no Siri, where am I? Or whatever.
Everything was Bluetooth, right? So it's not even, they can't even track its location. There's no GPS tracker that somebody on the surface can track where this thing's going. It's by cell signal. Yeah. Well, hell, I can't get my cell to work in the parking lot of work. Is it going to work at 4,000 meters?
Yeah.
Down at the bottom of the ocean? Probably not.
Yeah.
So that was another caveat to this, is like off the shelf Radio Shack equipment. That's not a dig at Radio Shack, everybody. But what I'm saying is that it's stuff that's made for a hobbyist use, not professional grade equipment.
Right.
Like who puts something that's going to go down to the bottom of the ocean that you can't track, and it pings its location via cell signal. Well, I don't know how about you, but I don't know how good cell signals work in the middle of the ocean and at 4,000 feet below it, or 4,000 meters below it.
Yeah.
It seemed very not well thought out. Like, how can I build the cheapest submersible I can and charge people hundreds of thousands of dollars to get inside of it and go down?
Yeah.
It's just that kind of, when you think about that, you're like, what do you mean there's no way to track it? Yeah, there's no way to track it. So, well, how are you guys going to locate it? Man, we're pinging sonar. That's all we're doing. We're a bunch of bats underwater.
Yeah. Yeah. And then from the very limited knowledge I know about sonar is when you cross certain depths, it's the signal that sonars put out at once it hits a certain depth, like the density just kind of bounces off. You know what I mean? So it's kind of like like those charts where you see like the different levels of the ocean. It's all colored different, like your light blue, dark blue, fucking black. Between those different zones, there's like different densities from what I understand. And sometimes the density fucks with the sonar. So like when they shoot it off, it doesn't exactly go through it. It kind of bounces or scatters or some shit like that. It's kind of like throwing sound against a wall. Like it's not going to go through all the way. Some of it's going to bounce off. So for all we know, and that's with like professional grade sonar. Now imagine like if we're using like low end, very hobbyist style equipment. How trustworthy is that? And case in point, like with this one interviewer, like we said, when he went down last year, they lost signal. They couldn't find the fucking thing for hours on end. That must have been some scary shit. Like for the people down up on the surface, like, yo, where the hell did the sub go? And then the guys in the sub, like, where the fuck are we? And for all you know, instead of going up, they're going down and just going further into the abyss for fucking the Kraken or some shit to come get them, you know?
Well, yeah, I mean, they suspect, you know, all right, did it actually land within the wreckage of the Titanic? Because that's another thing. It couldn't really guide itself, right? If you saw pictures, there had like fans on the side and on the back and on the top of it, which looked like it would be for steering, but it actually said there was no way to steer it. It was just, you kind of like, we suspect the Titanic's in this area, bombs away. And you kind of float down to it. But I guess the fans could steer you a little bit, but they didn't seem like they were fully articulating. You know, there was no outboard riggers to adjust. From what I saw, again, I'm not the expert here, but from what I've heard in different articles, and right, you know, two sides to every pancake, and you know, no matter how flat you make it or whatever. But they said it was pretty much just a weight that you had to drop in the location of the Titanic and hope that your aim was true.
Jeez.
And they suspect it might have gotten caught, you know, initially caught on the Titanic, and that's what tore it apart. When they tried to get free of it, of the wreckage, they, you know, but as Six said earlier, it seems like the most logical, because they found debris but scattered around, seems like it was an implosion.
Yeah.
So that hull or that porthole lens probably gave way, as we alluded to earlier, right? It was only rated to 1,300 meters. And that porthole probably gave way, and then the whole thing just imploded on itself, which is, you know, unfortunate. I couldn't think of a more horrendous way to go. But they also suspect that maybe at the temperatures down there, because the hull wasn't very well insulated, right? So they suspect that you know, they could have almost frozen to death first before all that happened. I don't want to get too much into that. It's the more morbid side of things, but my God, terrible. But just the fact that you couldn't track that thing. So then a year ago, right? Let's go back to a year ago. They did a test a year ago, and they lost the thing. Nobody was inside, but they dropped it in the water and said, okay, let's ping the signals or whatever. Or let's see if we can find the old Titanic down there with some camera setups and stuff. Well, hell, they lost the thing then for 2 hours. And I think one of the emergency systems kicked off, which was a big inflatable balloon, and it brought it back to the surface. And that's the only way they got it back. But wouldn't you think then you go, okay. We didn't make it. We didn't even make it close. We lost it, so there's no way to track it. So we definitely need to come up with a better tracking system, or at least a waypoint marker of some type, you know?
Yeah.
And then, okay, our one failsafe worked, but what triggered it? Why did it set off? It was supposed to go all the way to 4,000 meters, and it set off at 1,000 meters, whatever. I don't know, whatever it was, but like, so that something caused that to trigger. What was that? You know, that's the purpose of test and development.
Yep.
Okay, this worked. Here we go. We got this. Holy cow, that was and you know, that was a massive failure. And it looks like the CEO almost looked at that and was like, that was a big success. It went down and we got it back. But I imagine everybody on the recovery boat was looking at him going, were you part of the same mission we were? Like, we're lucky to have this thing back.
Right.
You know, but it didn't do what we designed it to do. Well, yeah, but it went underwater and came back. Well, I guess by that token, let me jump in real quick and come back up. Well, I'm a submarine too. You know, it's just, you know, it seems like ego. What do they say? Pride goeth before the fall.
Yep.
And that seems like that's what happened in this situation.
Yeah, sadly it is. And we've seen all sorts of scenarios like this in the aviation world ourselves, right? And from small to big, right? Small examples being like home-built planes, for instance, or home restoration planes. Like a bunch of individuals that get pretty up-spirited or high spirits to restore a plane or build a plane themselves. They don't have a whole lot of know-how to do it, or they ask enough to kind of move along. And instead of like having like the second set of eyes or whatever have you to kind of knock around this thing and make sure it's fitted good, they just send it up and hope for the best. Which sadly so, like a lot of these type of air quote experimental planes, which is a flash of ego, or sorry, home-built planes or home-restored planes, as the flash of ego, has been one of the leading causes for crashes. Fancy enough. Another example of like where the egos take over is like rushing planes through production, right? Because you're trying to make a sale or you're trying to beat out the competition. So I'll say like in a competitive scene, you kind of want to move fast and do things, you know, a little in a hasty manner, but there's certain checks that are made by certain regulations and certain standards for a reason. And then
that's the whole reason those standards exist, because otherwise, if there were no standards, I think aviation would have died with the Wright brothers.
Yeah, exactly. Right. Yeah.
Wouldn't be to the level it's at today.
Exactly, right? Or we're going to learn all our lessons. Well, we kind of do still, but almost all of our lessons we have, if had it not been for tests, would have all been written in blood. And a good chunk of them are. I'm sad to say a good chunk of them are. But and also a good percentage of that is because of stuff we found during a test, either through a controlled version or like it was very minimal risk to everybody else. So it's kind of like, well, if this thing wrecks, then at least we know it's only going to be contained in this little area instead of like fucking everybody, right? Example is like saying rushing flight software, right? It's never been tested before. It's never been ran on a flight before. And so like, you know what, full send, roll it. And then next thing you know, this thing pitches into the dirt thinking it's going down, going lower, not higher, or it reverses the controls. You're trying to pull up and it's going down faster. Or another one is like, say, like experimental GPS, where like if this thing crosses a different time zone, it think it went into the future and it just fucking lawn darts itself into the nearest cliffside because it can't deal with being in the future or some shit like that. And
yeah, I mean, think about your nav charts, right? Yeah. Any avionics techs listening, how every month you got to load new nav charts, right? Those nav charts are updated to reflect different traffic patterns, different things that are, you know, no fly zones that the military's put out for that month, different you name it. I'm not it's been a while since I've done that, so I apologize, but all sorts of nav charts and stuff that you have to load into the aircraft monthly. Think about that, right? Think about just that alone that you do for an aircraft that wasn't done for that submersible. They didn't load any depth gauges or meters. It says, okay, we're at X amount of feet. Look for this, blah, blah, blah. This submersible should be doing something at that time, right? Mm-hmm. So that's the same thing with, in the aviation. Like, we do all these things to ensure that those aircraft get off the ground, do their mission safely, get back, no harm. Everything's perfect. Reset, redo.
Mm-hmm. So, I mean, you're absolutely right. And, like, imagine that level of care we have to put forth for things that leave above ground. Same sort of things happen for the ones that go below the surface. And the fact that some of these, for lack of a better word, like accusations, are saying like they didn't perform any of these things. And I'm kind of leaning in that direction too. It's like, it sounds like a lot of the steps were skipped, right? A lot of testing wasn't done properly. A lot of standards weren't followed to the T. And I'll admit there's some standards that are a little convoluted or they're all over the place. So kind of navigating your way through it's a little messy. I get it. But at the same time, you know, like it's one of those, like you should probably like double check with somebody, right? Or some kind of entity like, hey, are we on the right track with this thing? Like, are we moving forward? And sometimes like it may seem convoluted, it may seem a little too much, but you know, like what's the risk of doing it versus not, right? That's where we kind of go into that cost benefit analysis where like, if we were to skip this step, what are we gaining? What are we losing? If we do this step, what are we gaining? What are we losing? And so forth and so forth. In this example, the cost benefit would be like, well, it's going to take a little longer for us to do this, but the chance of this thing getting crushed like a soda can in a trash compactor is probably less. And it's a bad call, like however you say it, however you see it, like in the events that happen as of today. But again, that is what MVP and I have been stressing, like the testing that goes into these parts, the testing that goes into the certification of certain things, even on us on the line, just doing routine day-to-day maintenance, like the pre-op checks, the hydraulic test, the maxi taxi, I guess that's the way to call it, high-speed taxi test. I'm sorry, maxi taxi. These may sound a waste of time. This may sound like, oh man, now we got to pay people to do this. We got to man personnel to do this just to have it roll, like burn skids or burn tires for 50 feet. Yeah, like because we've seen it time before where an aircraft goes to do a high-speed taxi test. It hits the brakes and it skids off into the freaking dirt. We're lucky that all it did was skid off into the dirt. But imagine like if something more serious happened, like the brakes didn't go at all and it goes full speed into a building, or the aircraft, like the autopilot or something kicks in, thinks it's losing altitude and it tries to max power and take off, you know, stuff like that. So a lot of these like tests, these operational checks, these functional flight checks, and all sorts of ground support equipment tests and certifications, they exist for reasons exactly like this, to mitigate that chance of risk. And then say example for like the submarine. I'm not an expert myself on what a submarine's supposed to be certified by or how, but I'd imagine it's almost as intense, if not more
pretty
intense.
Rigorous, I would think, right?
Yeah, exactly. I would think it would be just as, if not more, than an aircraft, because it's dealing
FSA
with
or something, Federal Submarine Association. I made that up, but you know,
right? I would think, right? Something like that. So help us out, somebody. Like, if what does a submarine have to go through to be rated at its depth? And I would imagine it kind of goes through a lot, especially because if it's spending majority of its time under the surface, if at minimum, I don't know, hundreds of thousands of pounds of pressure just from the outside, from the water. And that's like under prime conditions, which is another thing that these articles were saying about the submersible is like to visit the Titanic or to even do studies on the Titanic, there's like maybe a 2 to 3 month window for you to do it. And the reason why is because like weather plays a huge part in that area. And I've only traveled around the Atlantic maybe once or twice, and most of the times it was calm seas, but I'd imagine it'd be extremely rough. So, and especially I think like there's certain areas where it gets like heavy hurricane prone seasons. But from what these articles were saying, like there's only maybe a 2 to 3 month window to visit or to study the Titanic. And it's because of all the weather conditions and how that plays a role with underwater and all that stuff. So they said, or these articles said, that it's about maybe late June to about, or early July to about the first couple weeks of September is when you can do those dives. And so here comes the submarine, does it just shy of July. just before the July season. So a lot of people are starting to question, like, well, why did they want to dive so early? Like, why they're like at the beginning of the season to go study that place. What was the big rush? Like, couldn't they waited a couple weeks? Could they just like, get it when they're in the middle of the season where it's like calmest? Who knows? But I think that kind of plays into what MVP said earlier, where it kind of goes into that ego of it all, right? Like, I want to be the first. I want to show up and show out with a bang or whatever. And we've seen time and again where attitudes like that, they pay off. When they pay off big, but usually big payoffs like that usually come with an extreme amount of risk.
Well, that's what they say the CEO was in that too. He was a person who was a high risk, high reward type thing. Like, he was willing to accept risk greater than he probably should have, obviously. Mm-hmm. Because all he was seeing was big reward. But like, Batman only got his good armor because Superman could forge it on the surface of the sun, right? Like, Batman wouldn't have been able to do that type thing.
Yeah, exactly. And we, like I said, we understand that mindset of high risk, high reward. Now, I will say, like, there's a big difference between calculated risk. Like, we know this is going to happen. And here's kind of like our steps to either mitigate it, avoid it, or accept it. And there's just blatantly not listening to it at all. Like, just whatever, get me there, Now, we can't speak to the mindset these guys have, but I will probably mention, like, if this thing has failed at least twice, that might be a sign, like, I might have taken a couple extra steps before I put actual people in it, maybe throw some crash dummies or something and kind of put some
something that would simulate how a human body would react to pressures down at those levels, right? And you could put sensors on them. I mean, think about like when you're doing stress testing, vibe checks or whatever. Has anybody out there ever hung an aircraft from big giant bungee cords essentially, and you shake the shit out of it with all these different Roselle, string gauges and things like that, and figuring out where the stresses and ripple effects are going and what causes what damage those could potentially cause. I mean, that's the kind of stuff that I would think you would be putting it into a pressure tank somewhere and saying, okay, let's shake the shit out of it. Let's increase pressure. We have pig carcasses in there because those are pretty similar to a human, and we have stress gauges attached to the carcasses to see what kind of pressures the animal or the carcass is feeling at certain depths and temperature changes, blah, blah, blah. Okay, well, we're down 1,000 meters and it's already 15 degrees Fahrenheit. We should probably insulate this better. Yeah. Oh, well, that adds weight and X, Y, Z. Cool. It's a good thing we're trying to sink then, But then with that, we got to revamp how we're going to get back to the surface. Just a myriad of things that should have been done. And then, so all of you, we work and you're like, oh my God, I've been on this test bird for 6 months. I'm so tired of doing tests. Is it necessary to do all this? Yeah, there's a reason it's being done. You may not see it at the time, but there's a reason it's being done. Mm-hmm. Or how about electrical power, right? We're doing electrical checks. Okay, an aircraft gets struck by lightning at altitude. Oh, okay, well, what causes it not to fry out its whole system, Bonding straps, static wicks, you name it. Mm-hmm. And so same thing for a submersible going down 4,000 meters. What's going to keep your electronics from freezing out or the pressures from crushing diodes and stuff? Again, I'm not super savvy with the effects of pressure on those equipment, but just speaking in general.
Right. Or imagine if the hull was only rated for so much and it sprung a leak and then that leak gets into all the electronic equipment. That'd be one of the saddest way to go is you got caught in a fire underwater. That's, yeah. But
Yeah,
Again,
that's a good point. Like, what was the fire suppression system within that? Or, okay, the electronics are routed through the hull, but what happens if the outer hull springs a leak? Or is it going to short out my electronics and I'm just floating blind? Or I don't know. Just a whole slew of things.
Yeah, a whole lot of what ifs, right? Like we're asking more questions than we have answered. But that's exactly what the point is, right? Like that's how you kind of brainstorm. Like, okay, what's our risk? What's our ways to mitigate it? Some of it just starts by asking what if questions, right? Like, and that's the same thing that applies to guys on the line. This applies to people in general aviation, AOG. Like, ask the what if? What happens if this or I do this? What's the effect if whatever the case? You can spin this however you want, but like
that's why you see like on the 787, right, when they put those carbon fiber wings on that thing back in the early days of it, they were testing it. They stress tested it to the point where they tried to touch. They almost touched wingtips over top of the fuselage. Those wings flexed that much before they snapped, and then same way when they flexed them down, they almost touched wingtips underneath of the fuselage. But that's the R&D side. You're gonna have to spend money to make money. So Boeing built 2 sets of wings, knowing full well that they were going to destroy them in the process. Like, we literally spent money to hundreds of thousands of dollars to build these, to knowing that we're going to strap a bunch of gauges to them and snap them in two.
Yeah.
But out of that, wow, we can take 15, 30 G's, whatever, in this aircraft, and these wings will be fine. And we'll never reach those. And if we do, something severe happened. But we're never going to reach those in normal flight. So we know that the engineering and the design and the materials we've chosen to build these wings are more than adequate to take whatever beating they're going to take on continued repetitive flights. But something I want to touch on that Six mentioned earlier was through flights, check flights, dailies, weeklies, phase maintenance. All those things are to ensure that the aircraft remains safe and sound. So same thing for submersibles. I got to imagine there's some type of check that's going on when they get back into port. Every so often, somebody's diving under that hull and inspecting the hull for damage and wear and corrosion, and doing underwater welding where they need to, and repairs. So with unfortunately with the whole Ocean Gate submersible, if it had made it back to the surface, would they have even done anything? Cool, throw it back on the boat. Let's head back to shore and wait for the next group of buyers, or next group of tourists. Would anything have been done? Oh, I'm sure something, maybe a little here and there, but probably not to the extent that it should have been.
Yeah, I would. That's another what if question. Like I would have, like, what was the routine on this thing, and that kind of touches base on some of the other stuff we have talked about, like survivorship bias, right? Like I would imagine if they've learned anything, they was like, okay, like it was a little cold, let's put some stuff here, or they'll aim direction on places where they saw stresses, but not in the areas where it should have been. And what I mean by this is, like, say, like for instance, like an aircraft gets shot full of holes, but it still flew its way back. It's like, okay, cool, let's fill those holes with plates or some kind of reinforced material, and without thinking, like, you know what, like, it still came home with all those holes in it, so maybe we should beef up the places that didn't have holes. Stuff like that, right? So I'm kind of going on a tangent here, but that kind of goes into the lessons learned of it all. Like the reasons why we have these tests is because we're placing the best effort, the best resources in the places that need it the most, like such as.
Were you just talking about the P-38?
I believe that's what it was.
Talking about the holes where it came back,
and it had
the whole thing was riddled. They're like, "Oh my god, we got to beef up these whole things," and we're like, and the engineers went, "Well, why? It made it back with all these. We just need to keep the pilot protected." So they put a titanium tub in the cockpit, and that's what the pilot flew in to protect him. and they left the rest of the airframe go. In fact, they drilled holes in the flaps so they could dive faster to keep up with the Japanese Zeros.
Yeah. So
Sorry.
no, you're absolutely right. That's exactly what it is. It's through that kind of extension or that type of feedback. We're like, okay, let's put it in the areas that matter the most instead of the areas where we think it matters. That's where I kind of went with the survivorship bias, because I would imagine if this sub were recovered and the people or didn't suffer any type of major injuries, they would have just been like, okay, let's put 2 Xbox controllers into this thing instead of 1, and focus their efforts in the survivorship bias of it all instead of like focusing on the areas that really needed the attention. Like, I don't know, a hull that's rated for 4,000 meters or maybe
or a backup, like almost scuba mask with small oxygen tanks in case you do have to abandon ship.
Yeah, right. Or like say like once it hits a certain depth and it loses contact, like it's supposed to like understand that
return to surface. Yeah.
Yeah, right. Like warning, and then come right back up. Kind of like how some GPS systems where like if it loses signal, it just kind of like floats around in a circle until it finds itself again, kind of thing. Yeah. At least that's would have been mine. That would have been mine. If there's something that prevents that, by all means tell us. But that's what kind of like what I would say. If I lose contact with surface for more than, I don't know, 20 minutes, that's like, okay, it's time for us to go up. It's time for us to surface. Fuck this. It's not the day to die,
Well, look at like NASA shuttle launches. How many times those get canceled because the wind picked up by 3 knots?
Yep.
Crosswind, right? Nope, canceled. Conditions aren't good enough. I mean, the same thing should be done in that regard. Hey, look, and I understand it's private sector stuff, but still, it should be one of those like, hey, we had our day of checks with the submersible, and we're pinging an error on redundant system number 3. Oh well, there's still 2 systems in place. Yes, but redundant system 3 isn't working. Why?
Yeah.
We need to figure that out. We can't send it down unless it's engineers determine that's an ME-eligible item for a submersible. But I'm just saying. There's sort of an example like, nope, hey, actually there's an underwater current today of 10 knots, and that could affect your trajectory towards the Titanic and throw you off course by approximately 5 miles per X amount of 1,000 feet. Oh, well then, I don't feel like being 5 miles further away from what I'm trying to do underwater, so
right,
scrap it for today.
Yeah, no shit. Or like, hey, we meant to shoot you towards the outside of the Titanic's hull, but instead we landed you in the middle of the freaking captain's fucking quarters, which you probably have a higher chance of getting stuck. I don't know. I mean, we're playing with some astronomy math at this point,
yeah. So that's a good point, though. But okay. Let's just say we get you down there. We're down there underwater, and you do get stuck. What's the recovery effort? Do we have another sub on standby that can go down with the little arms on it that can pull stuff out of the way and get you loose? Is there arms on the existing sub to push you away from stuff? Like, those are the what ifs that we were talking about earlier, like questions that need to be asked. And that's how we determine, stuff in aviation. What are we testing? Well, what's the mission we're doing? Well, we would like to be able to fly at 80,000 feet at Mach 3, and the temperatures are roughly this at that altitude. Okay, well, what kind of stressors might we occur, so there's lesser gravity? Well, we get random solar flares that fly through there at that level. The ozone doesn't stop them as much at that level, and it could fry our electronics. So we should probably focus on solar flare protection. Again, a ridiculous example, but an example nonetheless.
Yep. And speaking of that, like with the SR-71, just going off on another tangent, like a lot of the equipment there was the electronics were air quote not electronics, like because with the altitude they're at the speed that they're going, a lot of traditional electronics would just melt on that aircraft. So they figured a way to make a lot of their air quote electronics like hydraulically driven. So it acts in the same way as a computer does, but instead of circuits and electricity, it's hydraulic fluid. So what a bomb idea to do that, right? But again, like you would figure that out just by doing all these stress tests a bit instead of just like kind of watching a cartoon say, well, fucking SpongeBob did it, so why can't I? You know, and that's sadly how a lot of individuals think. Like, well, I saw it in a movie once, so we can totally do that, right? Or the R&D of NASA or the military or some other super billionaire person has the know-how to do this. I'm sure they have, but you know, like that, if they did, there would also be some kind of like regulatory step that would say, hey, you know, you might want to take a look at this first before you start sending Radio Shack equipment down to the depths of the abyss. You know, like for all we know, you might discover something that you're totally not looking for and not in a positive way, you know? So, case in point, like these things exist for a reason. These tests, as redundant, as painful as they can be, they exist for a reason. And although we'll address that some of them are a little convoluted, some of them are a little over the top, but that kind of goes into that what if scenario, right? Like that what happens if we don't do it, or what happens if we skip a step, or whatever have you. And then like other examples, like MVP said, like what if an emergency situation pops up? What if a
megalodon attacks? Right. Just so you all know, that is one of the thoughts out there that come to light.
That is one of the
and the reason behind it is because on that same continental shelf down towards the Carolinas, a great white shark was tagged. A 10-foot great white shark was tagged, and so they were watching its its swim patterns and what it was doing. And it was swimming at maybe 70 feet down, and then all of a sudden it dove about 2,000 feet in the span of like 10 to 15 seconds. But at the same time, the temperature increased to 72.5 degrees when it should have plummeted. And so the only way it could have done that was by being inside of something else. And then 4 days later, the tracking device made its way to the surface. So after whatever ate it and digested it, that tracker made it through the digestion system and floated back to surface and made it to shore. And that's where they were able to pull this data from. So some people were thinking that, a megalodon of types wrecked that thing down low.
I wouldn't doubt it. I mean, conspiracy theories aside, like I wouldn't doubt something would have done that, right? Because majority of the depths of that level and below are still have yet to be fully explored. So who knows what the fuck's down there, right? And I think that's why a lot of people actually have that sort of phobia with depths. I forget the actual name of the phobia. I'd have to Google it one day, but there's actually a fear of like ocean depth. Like they just see pictures of the depth, or they even just peer down, kind of like how people like are scared of heights. But it's the same way, except like they're just looking down into the depths of the abyss, pretty much. And I don't blame them. There's a whole lot of shit down there that we have no idea what the hell's in there. And for something like a megalodon or some other type of animal of that size to do some shit like that, don't doubt it whatsoever. It probably does exist. Like we know more about Mars than we do about the depths of our own ocean, So, yeah. Tangent aside. Any final thoughts at all about this MVP?
Nope. I say nope, and here I go talking again. No, not really. I don't think we covered most of it. Just know that there's a reason we do R&D and test.
Very much so. And on top of that, destructive testing, pre and post-op testing, phase maintenance, and all that stuff, as we mentioned throughout the episode. And, survivorship bias, if things actually did survive, that's something we have to combat with too. But hey, let us know what you guys think, as more evidence of this stuff comes to light, like what sort of things that you feel could have prevented it, and then what sort of stuff that can we take from this and apply to our daily lives too, especially in aviation, like the importance of testing, the importance of R&D, the importance of procedures and standards, and what sort of things that you feel like if they're not listened to can lead to something as disastrous as as a submersible losing itself in the water. Let us know in our comments. Let us know on the social medias, our emails, our website, whichever way is the easiest for you. The absolute best way to get in touch with us and interact with us is joining Patreon and getting onto our Discord channel. We have all sorts of discussions just like this, and we're learning more things by the day, just with the conversations from our patrons. And also we do some other things like playing or experimenting with different ideas, like with games or comics and stuff like that. But by all means, tell us what you guys think. And on that note, we thank you all again for listening, and we'll catch you all again on the next one. Bye, everybody.
Bye, everyone.
We would like to take this time to thank our patrons for supporting our show and allowing us to make episodes, maintain our gear, and create merch for all of our listeners. With special thanks to Erica Lamont, Chris Hawkins, Eric Shaw, Dan Schubert, Ryan Frushauer, Kyle Keir, Mike Sherwood, Caleb Stockhill, and Jennifer Brofer. Thank you all so much for your support and patronage. If you like our show, please support us on Patreon. You'll receive awesome perks like access to our private Discord, discounts and early access to our merch, first glimpse of our comics and other projects, and so much more. You can further support us and show off your prowess as an aircraft specialist by visiting our shop at cancelformaintenance.com. If you like classy or rugged watches, visit our affiliate Rockwell Time at rockwelltime.com. Use the code CX, the number 4MX to save 10% off your total order. If you have suggestions for the show or you'd like to be a guest on the show, send us a line on our contact us section at cancelformaintenance.com, and we'll do what we can to get both your ideas and yourself on the show. Please support us on social media like Facebook at Cancel for Maintenance, Instagram at CANX for Maintenance Podcast, or Twitter at CXMX Podcast. Please check out our new comic series on the Tapas app. Like, share, subscribe, and comment on our comics. Let us know what you think. Thank you all so much for your support and listenership, and we will catch you all next time.